Hello and welcome to my channel. In this video we are going to solve the second question from CIE IGCSE 058043 extended paper from May-June 2024. Now this question is from sequences topic. The nth term of a sequence is 120 minus n to the power of 3. Find the fourth term of this sequence. Now here the nth term or the rule of the sequence is already given, that is 120 minus n to the power of 3. We have to find out the fourth term of this sequence, which means we have to just put n is equal to 4 in the above rule to get the fourth term. So n is equal to 4, so we write here 120 minus 4 to the power of 3. Let us see what value this gives us. So this will give us a value as 56. So the fourth term of the sequence is 56. Find the value of n when the nth term is minus 1211. Now here they have given us the rule for nth term of the sequence, that is 120 minus n cube, and here in the second question they have given us the value of nth term, that is minus 1211. So we are going to equate this number to this rule. So here I have written the nth term as an is equal to 120 minus n cube. An is given as minus 1211 is equal to 120 minus n cube. Now I'm going to take minus n cube on the left hand side, and at the same time I'll take this number on the right hand side. So we have n to the power of 3 minus n cube becomes plus n cube is equal to 120 minus 1211 becomes plus 1211. So when we add this number we get 1331. Now n cube is equal to this number. Let us take this cube on the other side of equal to sign. So it turns out to be the cube root of 1331, and this will give us the value of n as 11. So here our answer n is equal to 11. Now the nth term of a different sequence is 3 times 0.2 to the power of n minus 1. Find the fifth term of the sequence. Again here the n value is given to us as equal to 5. So we are just going to plug in the value of n is equal to 5 in this rule. So here we have written 3 times 0.2 to the power of 5 minus 1. So let us see what value this gives us. It's going to be 3 times 0.2, 5 minus 1 becomes 4. So here we have the value as 3 over 625. So this is the fifth term of this sequence. Now let us move on to the next question. The table shows the first 4 terms of the sequences A, B and C. Complete the table for each sequence. So here we can see 3 sequences are given. Here we need to find out the fifth term as well as the nth term for each sequence. Now let us begin with the sequence A. Now for A we can see that the first term is 7, second term is 4, third term is 1. We see a pattern over here, that is 7 minus 3 gives us 4, 4 minus 3 gives us 1, and 1 minus 3 gives us negative 2. So there is a common difference for the sequence. So here the fifth term we can say that minus 2 and minus 3 will give us negative 5. Now to find out the nth term of the sequence, I am going to use a formula. Sequence A is equal to an, that is the nth term, is equal to a1, that is the first term of the sequence, plus n minus 1 times d. D represents the common difference. Now this formula is used to find out the nth term of an arithmetic progression. We get arithmetic progression wherever we have a common difference. Now here our first term of the sequence is 7. So a1 is going to be 7. D is the common difference, which is negative 3. We saw that. So here we are going to write d is equal to negative 3. Now we are going to plug in the values of a1 and d in this formula. So we have an is equal to 7 plus n minus 1 times negative 3. Now I'm going to expand this bracket, that is 7 stays the same, negative 3 multiplies with n giving us negative 3n, and negative 3 multiplies with negative 1 giving us positive 3. Now an will be equal to 7 plus 3 will be 10 minus 3n. So this is the nth term of this given sequence. So let us write here 10 minus 3n. This is our nth term. Now moving on to the B sequence. Now here we see a certain pattern in the numerator and in the denominator. In the numerator we have 1, it starts with 1, 2, 3, 4. So we can say that the numerator of the fifth term is going to be 5 over Now in the denominator you can see it is 4, 5, 6, 7. So it is going to be 8 over here. So here we have 5 over 8. Now to generate the nth term, we can see that the numerator starts with 1. So 1, 2, 3, 4, 5. It goes on till the nth term. So the numerator is going to be n over. Now in the denominator we can see it is going to be n plus 3. That is 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7, and so on. So in the denominator we are going to write the nth term as n plus 3. So we have generated the sequence by looking at the pattern. Now for the C1. Now let us see if there is a common difference for this given sequence. Let me write it over here. Now for the sequence C, let us say it's been given that it is 0, 2, 6 and 12. So let us find out the common difference. That is 2 minus 0 gives us 2, 6 minus 2 gives us 4, and 12 minus 6 gives us 6. Common difference is not same as it was in sequence A. So let us try to subtract them again. That is 4 minus 2 we get 2, and 6 minus 4 we get 2. Now the common difference has become same. Now here we had to do 2 steps to get the common difference. So wherever we get the common difference after 2 subtractions of the sequences, we are going to make use of the quadratic sequences. Now once we have generated this, we need to make use of certain formula for this sequence, and this sequence. So let me write here. Now remember these formulae for each sequence generated. So for the first sequence we are going to use the formula a plus b plus c is equal to the first term of the sequence. Now for the second sequence we have got, it is going to be 3a plus b is equal to the first term of the sequence, which is 2. Finally we are going to take 2a is equal to the first term of the sequence 2. So I'm going to start solving from the last, that is 2a is equal to 2. So let me write here 2a is equal to 2. So this will directly give us the value of a, that is a is equal to 2 over 2, which gives us 1. So we have the value of a with us. Next let us try to find out 3a plus b equal to 2. So here we are going to write 3a plus b is equal to 2. Now we have the value of a with us, which is 1. So 3 times 1 gives us 3 plus b is equal to 2. And taking 3 on the other side of the equal to sign, we get b is equal to 2 minus 3, which gives us negative 1. So we got the value of b as well. Now finally let us use a plus b plus c equal to 0 to get the value of c. So here we have a plus b plus c is equal to 0. We have the value of a with us as 1. We have the value of b with us as negative 1 plus c is equal to 0. Now 1 minus 1 becomes 0. So the value of c we have is 0. Now we found out the value of a, b and c because the quadratic sequences are written by the formula an square plus bn plus c. Remember, this is how we represent the quadratic sequences. Now here we are going to just plug in the values of a, b and c to get the nth term of the sequence. So here a was 1, so it's going to be 1n square or just n square. B was negative 1, so we are going to write it as negative 1n or negative n. And c is 0, so we are not going to write the c. So the sequence generated for the sequence c is n square minus n. So remember that if we have a sequence this way, try to find out the common difference till you get a common difference this way. So here we took the first common difference of the sequence, and then we again took a common difference of the sequence, and after getting that we got the common difference same. So after getting the same common difference, we have made use of these formulae, that is a plus b plus c, 3a plus b and 2a. And using these three formulas, we have found out the values of a, b and c. And once we get the values of a, b and c, we are going to take the quadratic sequence formula and plug in the values of a, b and c in this. Now let us find out what is the fifth term of the sequence. So here we are going to just plug in the value of n as 5. So it's going to be 5 square minus 5. 5 square is 25. So 25 minus 5 is going to give us 20. So the fifth term of this sequence is 20. So here we have written 20 and the nth term is n square minus n. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out these playlists where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.